All right, so we've explored how virtual private clouds are kind of a partition of the broader AWS cloud infrastructure. As it turns out, you can partition your virtual private cloud even further, and you can control what kind of traffic is allowed into your networks and out of your networks. So let's talk subnets and access. Go ahead and watch this video. You can pause and watch it on the lecture slides. Once you're ready, we'll go ahead and continue. All right, so we're going to do virtual private clouds in the context of a coffee shop. So we're bringing back the coffee shop analogy. And it's going to help us explain the role of subnets. I know we haven't defined that term yet, but it's going to give us a good idea of how they work. So usually, right, customers will give their orders to the cashier. And from there, that order is passed on to the barista. This is an efficient process, right? Because it's going to allow everything to run smoothly. Cashier has one job, barista has another. There's not an intermixing, right, of the roles. But say that there's some customers, they're in a hurry, they try to skip the cashier line, it's too long, and they try to give their orders directly to the barista. This would definitely disrupt that efficient flow of customers, of orders, of actually making the orders right. And let's see what that would look like essentially. So usually customers have to first give their orders to a cashier. And then once the cashier accepts the order right, they handle the money, they ensure that everything is as it should be. Once that order is ready to be made, it's going to be handed over to the barista. Now, if we create this connection here, right, we're kind of bypassing this natural flow of information, of orders in this case. And definitely not the most efficient way. And why is that, right? Because the barista is now going to be having to handle both orders and making the orders. So why is that bad? Well, every time that the customer skips the line and goes straight to the barista, they're going to have to stop making orders. So that's going to slow things down. It's not going to be as efficient. They're going to have to wash their hands, right? They're handling money and so forth, right? It's just not the best way to do things. So to fix this disruption, the owners of the coffee shop decide to divide the counter area. So now there's going to be a cashier station and a barista station. The cashier station is public facing. That means customers have easy access to the cashiers, right, to the registers. The barista's area, on the other hand, their station is private. There's really no way for customers to even access the barista. So that eliminates, right, any awkward situations where the customer's trying to talk directly to the barista. It's going to break the flow, right, of orders, of making the orders. This is definitely more efficient when you split things up. So we have a public and a private station. So let's take a look at the new updated diagram, right? So now customers give their orders to the cashier. If they try to go to the barista, there's no way they can do it, right? They're blocked from doing that. So this inefficiency, this bypass has been eliminated from the workflow. So as we can see, right, the cashier icon has an arrow pointing to the barista icon. So if you want to get information to the barista, you got to go through the cashier first. There's no other way. They're public facing, they're private facing. They still get information, right? It's not like they're isolated, but the cashier is the only one that could hand over the information to them. So this is similar how you can use AWS networking services to isolate resources and determine exactly how network traffic flows. So yeah, just like the VPC is a partition of the broader AWS cloud, you can also partition the actual virtual private cloud into smaller pieces. Just like the coffee shop that's divided into a cashier and barista station, you can also partition a virtual private cloud. When you partition these virtual private clouds, they're called subnets. They're basically separate areas that are used to group together resources. And just like we saw with the baristas, there's going to be public and private resources. So what is a subnet? Let's finally define that term. So subnet is a smaller segmented part of a larger network. In AWS, subnets are a section of a VPC in which you can group resources based on security or operational needs. So they can be public or private. So why would you want a public subnet? In what cases would you give access to the broader internet, right, to access those resources, to enter that side of your application. The application, right, being the coffee shop. Well, let's say you have an online store, right? You want customers to be able to go to your website, to your homepage, to shop around. That's going to be a public subnet, absolutely. Now, the other side of your app might be storing personal information, such as passwords, addresses, payment info. That's got to go in the private subnet. You don't want just anybody walking straight into that part. Just like we don't want anyone going straight to the baristas. In private subnets, you want to limit access to these resources. And again, a good example, right, is like a database containing customers' personal info. So here we have our diagram, right? We have a public subnet and a private subnet. So now we have our AWS cloud. You cut a little piece of the cloud. You have your VPC. And then you cut the VPC into even smaller pieces called subnets. And then why do we cut them into smaller pieces? Because some of them should be public, some of them should be private. So for example, you have an app that has an EC2 instance. So if your app is like an e-commerce site, a store, online marketplace, you're going to want that to be public. And remember, the way that users actually get to the VPC is through a gateway, right? So that's kind of missing from this diagram is the gateway. You can't get to the VPC unless you have a bridge into this section of the AWS cloud. And remember, there's two types of gateways. There's the broader public internet gateway, and then there's the virtual private gateway. So similar to subnets, but the gateways are more about how you enter the entire VPC. Subnets are a smaller partition of the VPC. So for example, you have an app that has EC2 instances. They're here on the public subnet. And then you have your database with sensitive info in the private subnet. Now, people coming in through the gateway can access the public subnet. Easy peasy. Now, if they're trying to get to the private subnet, all that sensitive information, right? Other users' passwords, payment info, they can't access that. They're not going to be let in. There's a block there, right? They're not going to be able to bypass their way into that. That's not to say, though, that your app, right, still has to get this personal info. If the user is going to log in, they have to go and check the database to say, oh, is this an existing user? Oh, they want to make a payment. Let's get their payment info. So the public subnet can talk to the private subnet, but people coming in through the gateway to the VPC can only hit the public subnet. So the private subnet's protected in that sense. So orders, right, is what kind of was going in the coffee shop. Orders would get to the cashier first and then eventually to your barista. Instead of orders, we got packets. So packets is what our networks are working with. And packet is just another name for a unit of data. So you're sending information. It could be video data, right? Picture data, order data, all kinds of data. It could be password, right? Encrypted data like that. So yeah, those packets or data sent over the network, that's what's coming in and out of the subnets. So packages enter the VPC through the gateway, like we said. There's a bridge that needs to be coming in here so that the package can actually make its way there. You can imagine if there's no bridge, right? The packet would just go straight into the ocean or something like that. So yeah, packets enter the VPC through a gateway, whether it's public or private, right? That's a different discussion. Before a packet can enter a subnet, it's got to check for permissions. Do you have permission to enter this subnet? Especially if it's a private subnet, right? Do you have permission to access these resources? Who's actually checking, right, for these permissions? One example of a component that could check packet permissions as they enter a subnet or exit a subnet are going to be network access control lists, or ACLs. So they're kind of like they're the ones controlling, right, inward and outward traffic into the subnets. So we're going to need a different analogy this time. But before we get to that, just a little diagram. So you can see here the network access control list, right? That's kind of like the master list deciding who goes in and who's denied entry. That could be to a public subnet, but I think it makes better sense to think of it for a private subnet. Though you can have rules, right, for both public and private. Yeah, even though it's public, right? Even though it's accessible to the broader internet, you can still kind of limit what kind of information goes in and out. All right, so like I said, we're gonna need a different analogy. Coffee shop's not gonna work anymore. So let's go with an airport. So the ACL, the access control list, is like the passport control officer. So when travelers are going in and out of different countries, the passport control officer is going to check the traveler's credentials to make sure that they are allowed to enter and exit out of the country. They're not really remembering whether or not that person already came in. Because if you came into the country, right, you should be allowed to go back naturally, right? But the passport control officer, they're not going to remember you. They're going to check you both ways. And they're going to go back to that access control list, right, or that master list to make sure, hey, is this person allowed to go in and out? Well, that's what the ACL does with packets. It says, hey, as a packet is floating into the subnet, are you allowed to come in? Let me check my control list. Okay, you're good. Go ahead. And if there's like a response, right, that needs to come out of the subnet, they're going to do the same thing as they go out, just like the passport control officer. So if they're not approved on the list or explicitly on a list of banned travelers, they cannot come in, right? So yeah, you either got to be approved or you could even be explicitly denied. Same with ACLs. So each AWS account includes a default network ACL. So the default ACL, when you make a VPC, is just wide open. By default, all inbound and outbound traffic can go in. Now, if you start adding custom ACLs, by default, they're going to deny all traffic because they're waiting for you to give the permissions, right? Who can come in and who can come out. So when you create a VPC, by default, everything can come in. You start adding other rules, then you got to configure those rules. Otherwise, nothing's going to be allowed in and out. Additionally, all network ACLs have an explicit deny rule. So this ensures that if a packet doesn't match any of the rules on the list, the packet's denied, right? If you're not approved, then makes sense. You're denied, right? You're not going to be let into the subnet, just like the passport control officer doesn't let you into the country. All right. So ACLs are called stateless. We're going to talk about stateless and stateful. They're stateless for really one big reason, because they don't keep track of previous traffic. They don't really remember you, just like the passport control officer. So many people are coming in and out. I'm sure they have records, right, of who's coming in and out, but the actual passport control officer, they're not really going to remember who you are. So they're going to treat you just like everybody else. They're going to check you just as much as they did when you were coming in as you were coming out. Of course, right, flight security safety is top notch these days. So just like that, the ACL is also checking in as things go in and out. Each request and response must be explicitly allowed by separate rules. So recall the previous example of a traveler who wants to enter into a different country. This is similar to sending a request out from an Amazon EC2 instance and to the internet. So yeah, maybe your instance is making a request to the internet, an API, right? For example, we've talked about APIs. If they want to get that information, if they want to go outside of the subnet, they got to have permission on the ACL. And remember, ACLs are stateless because they just don't keep track. They don't remember anything. They're kind of dumb in a sense, right? Not as efficient. So let's look at stateless packet filtering. So as the ACL is letting things in and out. So if you're a traveler, they say, I'd like to enter. Let me check if you're on the list. That's what the passport control officer says. Same if you want to exit. The passport control officer is going to do the same thing. They don't remember. Maybe not super efficient, right? But in terms of safety, it gets the job done. Same with ACLs. Maybe not the most efficient way, right? Because naturally, if you have a request coming out, you probably want to let the corresponding response in. Just like if you had a traveler come into the country, you should probably let them out. I know it doesn't work that way in the real world, right? But just for the sake of this analogy. But yeah, that's how ACLs work. They're checking in and out. They're not really remembering anything. So network ACLs check the packet response against its list of rules to determine whether to allow or deny. After a packet has entered the subnet, it must have its permissions evaluated. So even though it came in just fine, as it comes out, it's got to also check. But what component is in charge of checking packet permissions?